Okay, let's start with A3. So it says a slingshot consists of a light leather cup attached between two rubber bands. If it takes a force of 32 newtons, so I'm going to write my given. F is equal to 32 newtons. To stretch the band 1.2 centimeters, so X is equal to 1.2 centimeters. Now remember, with Hooke's law, the displacement and the force are going in opposite directions. So if this is positive, this is going to be negative. Now right off, I see that this is in centimeters. So I always want to put it, because a newton is a kilogram meter per second squared, I have to convert this centimeters to meters. So I'm just going to move it two places. So X is equal to 0.012 meters. And it says, what is the spring constant? K. So I know that F is equal to minus Kx. So K is equal to minus F over X. So it's equal to negative 32 newtons divided by negative 0.12 meters. Now remember, if I look at it, so the negative in the numerator cancels with the negative in the denominator, and I don't have a negative. And now when I take my calculator, I say 32 divided by 0.012 equals, so I get this big number, 2666.67. Now, first let me check my unit. So I have newtons in the numerator. So remember, a newton is a kilogram meter per second squared divided by a meter. Oh, I'm going to leave this because the unit, is a newton per meter for spring constant. I forgot we're solving for K. And then if I want to put this in correct significant figures, I see that this has 2 and this has 2, so my final answer should have 2. So that would end up being 2.7 times 10 to the 3 newtons per meter. And that's my final answer. That's it. Now we're going to move on to practice B. Now because the example problem I put in the notes, it has me solve for little g. Now I'm going to do number 1 because number 1 solves for L. And again, you don't want to plug numbers into your equation. You want to rearrange the equation to solve for the unknown in terms of the known. So we're going to look at B1. So B1 says, if the period of the pendulum in the preceding sample problem was 24, so I'm going to write my given, and t is equal to 24 seconds, how tall would the tower be? So I want to find L. Now, because the sample problem said you need to know the height of a tower, but the darkness, you note the pendulum extending from the ceiling almost touches the floor. So it's pretty much the same problem. So first of all, if I write down the equation, I know that T is equal to 2 pi times the square root of L over G. And I want to solve for L. The problem is I only have one thing in my given. Well, the other thing I know is that G is equal to 9.8 meters per second squared. So I'm going to rearrange the equation to solve for the unknown in terms of the known. My unknown is L. So what I'm going to do right now is I'm going to leave out whatever it is. So first, I'm going to get rid of the 2 pi. So I'm going to divide that. So T divided by 2 pi is equal to the square root of L over G. Now I want to get rid of the radical, so I want to square both sides. So I'm going to say that T divided by 2 pi squared is equal to L over G. Because when I square this, remember I'm squaring this. Now, this is where people make their most common mistake. When you square this, not only are you squaring the numerator and the denominator, you can't forget about that pi. So that's going to be t squared over 4 pi squared is equal to L over G. And this is where people always make a mistake. When you're plugging numbers in or you're just trying to do it on your calculator, you're going to make a mistake. Whenever you get to the point you have a fraction, your best friend is to cross multiply. So I'm going to cross multiply. So that means this times this is equal to this times that. So I'm going to say t squared g is equal to L 4 pi squared. And after I get to this point, I'm going to say to myself, what am I actually solving for? Well, I'm solving for L. So I'm going to leave L by itself, and I'm just going to move everything else. So because this is multiplication, I'm going to divide. So I end up with t squared g over 4 pi squared is equal to L. Now when I substitute in my values and put in my calculator, I'm not going to make a mistake. So L is going to be t squared, which is going to be 24 squared times g divided by 4 pi squared. And you know, pi, put 3.14. If you just use the pi button, your number is going to be bigger because pi is going to show like 3.14, like 1.5, however far your calculator goes in decimal places. So when we do this on our calculator, we end up with 143 meters. But if we want to put it incorrect, it would be 1.4 times 10 to the 2 significant figures. Again, if you look at your homework worksheet, your final answers in parentheses are always incorrect significant figures. Now let's look at the units. Because this, remember, in physics we have a foolproof way to always check our work. So the final unit should be meters, and look at all this. So we have seconds squared here. Then here we have meters per second squared. And then in the denominator, what do we have? We don't have any units, right? So this cancels with that, and we end up with meters. Is that the correct unit? See how quick it was for me to just carry my units through and check them? I could do that in just a few seconds, but it's a foolproof way to make sure I did not make an algebra mistake. So that little bit of extra effort to carry the unit and check it, I have a foolproof way to always check my work in physics, and that's what's so great about it. And that's it.